and this is the 2015 Facilities Geospatial Technology Showcase. This 6-month webinar series is hosted by the Campus Facilities Technology Association and organized by the University of Kentucky. I'm Michelle Ellington, and I want to thank all of our attendees joining us today. We have 55 with us from around North America. Today's webinar is being recorded. Both the recording and slides will be made available on the CFTA website. The presentation is estimated to run around 45 minutes with the remaining time dedicated for Q&A. Feel free to send any questions during the presentation using the questions dialog box. Your question will be added to the queue and answered at the end or as time allows. I want to extend a special thank you to today's presenter, Scott Stocking. Scott serves as a spatial data interface analyst for the University of Chicago. He will be presenting on their Spatial Data Infrastructure Program, which is a central data repository of geospatial information used in campus-wide enterprise applications. Scott, thank you so much for being here today.
Well, thank you, Michelle, and thanks again to everybody joining, and Happy New Year. We're going to spend a little time this afternoon to talk about our Spatial Data Infrastructure Program at the University of Chicago. We started this program about 2 years ago when I joined the university, and we've been making some steady progress, and we'll show some of the results of that work as well as some future endeavors and just the overall program plan for the implementation of the SDI. So with that, I'll kind of go through the outline of the presentation. We'll just have a very short overview of the University and Facility Services Department, the department I work for. We'll talk about the story, so how it all came about and how we started down this path. And then we'll move on to some of the major components of the SDI program. We'll focus on the 3 big items in the program. There are many other components, but these are the 3 major ones we'll cover over this afternoon. Then we'll talk about what it's all about, supporting operations. So we'll get into some of the current things we do and some of the future things we would like to do, and how the SDI will kind of plug into that process. And then we'll move in a little bit on the conceptual design, so you'll kind of understand how the overall SDI has been put together and how we're planning on building it, where we are in the process, the current status, and then finally next steps. So in terms of the schedule and what we're planning on doing down the line. Okay, so that would be what we'll cover today. So with that, let's move in and talk about the University Facility Services Department. So again, the University of Chicago, it's a worldwide facility. We have facilities all over the world. We have a major medical center on campus. We also have a number of major national labs associated with the university. So we have Woods Hole, Oceanography, Fermilab, and Argonne here in Chicago. We have nearly $500 million a year in research, around 400 buildings or so, and 20 million square feet. And the Facilities Services Department is divided out into essentially 4 divisions. So we cover the full range: planning, design, construction, and operation. And in talking with other folks in the different universities around the country, that's not always the case. So we've been very fortunate where we have all 4 of those major domains in one department, and that helps a great deal, obviously. So that's one really big benefit that we have here at the University of Chicago, is that we do have all 4 of those under one umbrella. So with that overview, in terms of where we are as a school, let's go in and say the story begins. So the story is, basically I was brought in initially, says we need to build a GIS. So we're talking about bringing it up, trying to put some data into the GIS, mainly in utilities and grounds, things that aren't currently covered in the facilities department in a digital format. But the silos, the silos problem, the data problem where we've got all these data sources coming in. So basically in looking at it, we have both GIS and BIM coming online, where we're in the process of establishing our BIM standards now and really taking advantage of some of the BIM technology. GIS obviously is just starting with me coming on board and putting in utility information in the grounds data. So we've got some data sources coming in there. We already have a huge repository of CAD drawings that are bus facilities management uses, and that's by far the largest digital repository we have in the department. Add to that the LiDAR point clouds, where we're actually going in and doing the scanning of the building, so now we even have more data. So basically it gets down to the point is, so what's correct? You know, the point would be that you'd be spending all your time within these 4 areas trying to determine what the actual existing condition is, because you would have data in some cases, depending on what it is, in all 4 of these areas. So with that, I came up with an approach that we need to utilize all the spatial data that's in our repository, which comes out to the SDI. So the big thing on this is it's just not CAD, BIM, or GIS data, it's all spatial data. And our department definitely understands that, and the reason why we started this whole effort was to get on top of that and try to find a way to manage all these data sources. So with that, let's go into the goals and objectives. So the goals, again, it's lofty. We want to have an fully interoperable system to add value both in operations of the university and the academic mission of the university. So that's important, again, because we work for a university. We have faculty collaborating with folks that may want to use this data at some point in time. So that's a big factor in the overall design. And they collaborate with people all over the world. So being interoperable is a pretty rigorous requirement. For the objectives, they're straightforward. We want to create a single version of reality, spatial reality. And since a lot of the information that we're creating right now in digital format was not in any way, shape, or form in any format whatsoever in GIS or BIM or so forth, we're starting it out as a 3D model. So that's another benefit for us starting at this stage. This will include all of our physical assets. And I mean by that, all major physical assets. So that we'll not include nuts and bolts. We'll include every single asset or potential asset that we have, but the major ones. It will model 3D and 4D capabilities. So we want to have both the ability to model the entire campus, underground, above ground, ground plane, in 3D, and also put a time factor on it. So be able to say what was past, current, and future. So we want to have that as part of the modeling process. And finally, we want to build it to an international open standard, so through the OGC. So that'll help a great deal in terms of meeting our interoperability requirements. So with that, how do we go about it? So we get into the major components of the SDI program. And it's this first concept is the open data model system of record concept. So we'll discuss that a little bit and what that actually means. Spatial accuracy, of course, is a very important consideration. And we were talking about how we're going to manage that process with different acquisition technology and different results, right? We'll be taking information from systems of record, from BIM models, from point clouds, and so forth. And they have varying degrees of spatial accuracy, and we have to manage that. And, of course, we have to do the support of the department operations, both existing and new. So we have to have a plan, a roadmap on how that all is actually going to get pushed over into the SDI and being able to utilize that spatial data for those areas. So the first thing we'll talk about is the open data model system of record concept. So the university has adopted the open data model in City GML. So we've basically said this is the target model that we're going to have as our spatial data infrastructure. And for those of you not familiar with the City GML, it's basically it was a system. It's more prevalent in Europe. It was developed by the Technical University of Berlin, and it handles geometry, level of detail, and ontology semantics in a way that's very, very unique and open and interoperable. So it handles a lot of these areas that come into factor and play in the spatial data model out of the box. It's a very open model. Obviously, it's not tied to any software or application format. So we've decided to adopt this as our target model. And this is sort of an example of a level of detail. And it makes a big difference, as you know, if you're always struggling with level of detail based on map scale and so forth. So they've got regional map scale at level of detail 1 all the way down to detailed three-dimensional models of building down at LD4 down at the bottom. They also deal with components of the infrastructure that you're interested in doing. So they've got building, city infrastructure, land use, and so forth as part of the modeling process. And they also allow for some extensions into these areas to kind of allow you to extend a little bit further beyond just the core data model. So City GML is a target. We're going to be harvesting basically the systems of record. They're coming in from CAD, BIM, and GIS. And the reason we're doing that, obviously, is we've got a lot of time and money already tied up in that, and also our vendors supply a lot of this data in these formats. So obviously we have to kind of maintain an infrastructure, at least for the near future or beyond, for that stuff. We also have applications that are plugged into those data sources, and they're not going to go away anytime soon, and we've got a lot of money tied up into that. So that's another good reason for keeping a system of record in there. But the City GML could potentially be used to add additional spatial objects in those environments, and that's kind of our plan. So a good example would be in a BIM environment, we may have a detailed BIM model running in Rivet, let's say, but we would put facilities and grounds data, infrastructure, piping, steam tunnels, and so forth as a City GML add-on that would plug into that environment and be component as the 3D model. So that's kind of the plan to sort of add additional information within that framework. Another nice thing about going with an OGC standard is they spend a lot of time and effort on open standards across areas that are going to be really huge for us down the line. So when I was first looking at how to deal with this, it's sort of like it was just too complex and large to handle it because of all the things that are coming on board with the open web services, the whole sensor area in smart cities, which I would argue is probably going to be the largest single infrastructure piece in the entire facilities division at some point in time in IT. And then also COBE, which is for the asset management side of things, getting it into your CMMS system. So OGC is spending a lot of time on these standards, and a lot of people are adopting them. And also as part of that process, they're making sure that the City GML spatial models can plug in and be usable in this environment. So they're helping manage that process for me, and it's a big, big deal, believe me. Once you start thinking about this and how you're actually going to push it and consume spatial data in these environments, this is really the only way to handle it. Okay, so let's talk a little bit more about some of the open system data model and system of record components. So obviously on the balances, the central repository, which will be in City GML, the big question is how much is enough? How much will we need to pull out of the systems of record to actually make it a usable spatial model? And I don't have the answer to that question. But obviously it's going to come in with things like walls, ceilings, pipes, but are we going to get down to valve levels? Are we going to get down to connections? Are we going to, what other components of the building are we going to get down to? Are we going to get into some of the components on the piping and the air conditioning units and the key assets, some of the expensive assets that we manage? Do we need to include that in the model? I'd have to say right now, at least initially, when we're going to roll it out, obviously we're not going to go in and get some of the larger facility data. It's just too complex to deal with. We're just trying to get three-dimensional volume and spatial accuracy and how all these different assets relate to one another. So we're not going to take on that issue right away, obviously, but it's just something we're going to have to discuss and work with our operations people and figure out what that good fit is. And there are a number of challenges in this process, obviously. One big one is that not all City GML standards are completely in place. So a good example of that is in an infrastructure. There really isn't a component. City GML is great for land cover and buildings where they spend a lot of time on it. but it hasn't dealt with a lot of civil engineering and items for utilities and things of that nature. They're starting it with infra GML and other efforts, and they will eventually come in place. And that's fine because we're not ready to take those things on anyway at this stage. But it is somewhat concerning that they're not currently there, and you can kind of look at them. Another one is a few software models actually run in City GML, and that is changing, and that's changing fairly rapidly. We just saw recently SRI's just put some additional support extensions in for City GML, and obviously the OGC through the Open Web Services there's a lot of plugins going in spatial models. Not so much in the United States, more in Europe and in East Asia, where some of this is actually going on with City GML in the background. Obviously, one of the huge things, as we are all concerned with, as people manage spatial data, is the spatial accuracy piece of it. So two main components on that. First is the data harvesting process from the systems of record, and then what we call data harmonization, which is basically trying to combine all those data sources into one single composite. And there are some significant modeling things that have to be managed as part of this process. One is what I show here on the screen, where the BIM technology in IFC is basically constructed solid geometry, and the City GML is boundary representation. Those are two completely different parametric, geometric modeling capabilities and concepts. There are abilities to map some of this. There's a lot of work going on in this right now, and I think over the next year or two you'll see some significant effort on this. We've started tackling this problem. But this is one that, it's just not right out of the box. I mean, they're both fundamentally different in how they handle their geometric structures. Other items of dealing with it is data acquired from different model and sources. So we have to deal with that in terms of, their accuracy, validating their model. So we also have different levels of accuracy. So for instance, in the GIS, we have data that's coming in from maybe 3 or 4 different data sources, and some of them are super accurate. They come in from LiDAR data. Some of them are survey controlled. That might be class 2 data. Some of them are coming in through orthophotography. It might be class 3. It's plus or minus a foot or 3 feet, depending on your orthophotography. So, all this has to get meshed together in one coherent system, and you have to keep track of that in the substitution process when you're trying to bring all this data in, where you don't want to take out class 1 data and replace it with class 3 data, even though it may actually be, quote, newer data. Its level of accuracy may not necessarily be up to speed with what's already in the system. Oftentimes the data is not coming in state plane. That's particularly the case in BIM. We're going to fix that with the BIM standard, where we adopt that and put that in state plane or make that a requirement, and try to deal with our vendors on this to make sure that the data comes in right out of the box, ready to go in state plane coordinates. So our plan on addressing this thing is, again, through standard and templates. So we're trying to create some methods and standardization process and trying to do the harvesting. So from the BIM process, we'll have some standard template formats that will make it easy, quote, to harvest the BIM elements that we want to pull out into the SDI and create some automated processes that just plug in that and pull it out. And obviously people are going to be a huge part of this process. We need program managers on the system of record in all the 3 main spatial data areas, and also SMEs and in some of the other components as well, just to help manage this process to make sure it all kind of lines up when we get deliverables from vendors that meet our standards and so forth. So for the data harmonization process, it's a very large, complex rule-based system. We've just started working on it. It's at many different levels. There's a geometric connectivity component of it, where you're going to have, obviously, data coming in at varying levels of accuracy that they won't actually join. So what do you do in those cases? As I mentioned before, the retain and replace area for systems of record and data classes. So being able to say, is this data source coming in from a system of record? If it is, it's already considered valid and going through some more rigor than, say, from a secondary class where we've got some steam pipe data coming in and a CAD drawing, but that's not the system of record. So we have to evaluate it sort of with a leery eye, if you would say. And then also data classes in just in terms of its level of accuracy in the data as it came in. And then this concept that I've come up with, which is sort of a coherent spatial unit for concepts of spatial objects. So when you move a wall or you move a floor, other things go with it. And you just can't move it without affecting other components, other spatial objects. So there's going to have to be some modeling capability to handle that complexity and make sure that we keep the integrity of the buildings, the rooms, and so forth intact. We're going to try to hit the 80-20 rule. With some manual review, a lot of it will be automated to the extent that we can through a rule base and other issues that we build. And we're obviously going to do this through Oracle Spatial, and Golden Gate technology will help us build some of the algorithms and work processes and workflows to punch this through. CityGML is a native data type in Oracle Spatial. Okay, so that's some of the modeling things really quick that we're going to be dealing with. Getting into some of the support operations and current, these are the things that we currently are running and we're going to need to maintain over time. So we have the space management Archibus, which runs only in CAD right now. Asset management, Maximo, we use Maximo. That can only use BIM and GIS if we choose to spatially enable it. Landscape architecture, that typically comes in as CAD drawings. And there's CAD systems that run on top of that information. So these things are what we currently have, and we're going to have to support those for the long term. So for future operations, we've got a couple things that we're working on right now. One is the space optimization routine with NASA Langley, with Brad Bell. He's going to give a talk in another couple weeks about their efforts out there. They've developed a really awesome ArcGIS server product that we would love to collaborate with them on to do a little more rigor on terms of our space optimization routines on campus than we currently use. That runs in GIS. It's our ArcGIS server application, so we're going to have to plan for that. The visualization part, which is a big part of what SDI is going to do for the central repository and what I call the virtual campus. And we'll talk a little bit about that and some of the work we've done so far. And then the map front end for a facility services catalog. So basically having a spatial catalog to get at all data sources within a department. So this visualization example here is just, again, trying to get it into a 3D world in an immersed environment. We'll talk a little bit about some of the work we've done on that. And then the link into the FS catalog. This is an example out of Europe with the Inspire effort and their GeoPortal. So basically being able to query on a map and pull up all related information associated with that, spatial and non-spatial. So that's the idea, is sort of being able to have a spatial front end on the catalog. And you might not know what room of building it's in or what you're actually trying to find, but you basically know where it's located. You can drill into that area, start clicking on things and being able to pull up information, warranty information, maintenance record information, what have you. It's just a good clearinghouse to quickly get to that information and compile what you need to get to. And then this final kicker, of course, is that you work for a major research university and got collaborators worldwide. So who knows what they're coming up with? And you know, there's a lot of work out there right now going in this area, and so obviously we have to be cognizant of that. And part of being an open standards process is going to help a great deal on that and being able to make the information very transportable. So just going over a little bit on the future operations, again, the NASA Space Optimization Program, some of its key functionality is it provides a really very cool schematic presentation of the campus. So basically taking a very complex three-dimensional model and making it into a simple 2D view that you can actually understand and work with. It also models some very important variables in space planning process that our planning and design people can't wait to get their hands on. So things like, elite faculty that can't be moved, key collaborators within departments, things that just, are very, very difficult and really not out there on any other product that we've been able to find that would really provide a lot of enlightenment for our planning and design people. And it does have a real-time based scenario application where you can move folks around and try out different scenarios and see what the cost representation of that information is. And it's just, we're hopeful that, over this next year that we'll be able to do some collaboration on this product. On the visualization process, again, the central repository, virtual campus, again, being able to do a consolidation of all the existing data sources into BIM, CAD, and GIS into one 3D model. We've worked with an advanced visualization system at the University of Illinois Chicago at their environmental visualization lab at the Cave 2 environment. I'll talk a little bit about that. And the reason why we did this is that visualization is a huge piece of what we're trying to do with the SDI and is a very complex part of the process in visualizing 3D space as close to reality as you can, and that informs a lot of the data modeling process and things that we have to look for as we move into the final CityGML model. So we started this last year, and we basically went through and did a consolidation of all our existing data sets. So we used CityEngine to do a base model for roads and buildings. We basically used FBX for our transport process into a common framework. We also did the same thing with some of our CAD building footprints that weren't in any other source other than CAD. We got it in the FBX. BIM we converted in Rivet into FBX, and then we ground truthed everything in 3ds Max into one environment. So we basically brought it in. So we were coming in with what I call a base plan, which may have most of the buildings in it and roads and some of the major features. Then we've got some CAD information. Then we've got 4 or 5 buildings in a full Rivet 3D model that gets pushed out as FBX into 3D Max. We also had some SketchUp data out there for textures and surfaces that we migrated via CityEngine into Culotta. And then we put it all into a Unity gaming software model for the final 3D model. So Unity is an open source gaming, video gaming software. I was kind of leery using it. I'm sort of like I'm now cool with my kids. I'm actually designing video games. But it actually was a great little tool, and it actually had a lot of quick utilities, very easy to use, was quick to bring up, and was robust enough to bring this model together. And it turns out that it worked out pretty well because the Environmental Visualization Lab at UIC actually uses it as one of their tools. So here's just a quick specification of the virtual campus that we built and some examples of what it looks like in Unity. 2 million objects, roughly, 2,000 texture files for the surfaces, or image and graphic files. Total model size is around 2.5 GB. And just mention this is actually a small model. It's only 4 models itself were in BIM. So this is an example down in the right example where you see the colored building, and that's actually a BIM 3D model. Some of the other buildings you see with footprints and extruded and so forth, those are just GIS data, footprints and so on, and the roads are GIS. And then this example on the left is just an interior view of the new hospital wing, which is a BIM model was brought in. So it's all brought into Unity and combined into one standard model. And then we pushed it into the most rigorous environment we could possibly get our hands on. And so UIC has what they call the Cave 2 environment. It's a very high resolution basic room that you walk in. It's stereoscopic. It's an immersed environment where it basically places you inside the model in the room, and you navigate through the model in the room, and at very high resolution, and it's pretty realistic. So it shows all your warts. so to speak. You can't really fool it very much as you're going through and viewing things. You see things pretty much as the way it's supposed to look. And since I can't show it, obviously, in an immersed environment, we'll just show some screenshots of the walls and things. So these are just some of the buildings we brought over. That on the right here is a BIM model. Straight ahead is a SketchUp model that's put over a shell of a GIS footprint. Let's see. We'll look up. Here's another example of sort of a ground plane view of that one building that's a BIM model. So basically, as you're walking on the ground plane here, you're walking through the campus at street level. You walk up to this building, you go through the stairwell here in the middle, and you enter the building. And it's all seamless. You're basically in an immersed 3D volume. And you feel like you're inside the room. You look around, there's walls on all four sides. You have ceiling and so forth. Really cool part is if you look through these windows, you see the rest of the model. So these are actual buildings on the campus, the rest of the model. So that's all part of the process. Same thing here, where you basically get the details and so forth of the building. So obviously it's huge to do some evaluation of buildings in this environment. Obviously it's very interactive. It's as realistic as we can make it. And so you can do some real evaluation of design alternatives on buildings, obviously using this infrastructure. And this is an example. This was a SketchUp building. It was done with photography. Again, it's a mishmash of everything we had, but we just threw it into one model. And this used actual photography as part of this is the Roby house on campus, or Flank Wright house. So you can just see, some of the detail. And we're just trying things out, seeing what works, what doesn't work, that kind of thing. So that's kind of a quick look at what we did for the visualization side. But now there's some things that have happened just recently that might change a lot of this. And one of the things I was going to talk about that's been different in this talk than maybe you've seen at the ESRI UC is there's this Euclideon group out of Australia who's developed this unlimited detail for point cloud technology, which is quite amazing. Basically, you can use data sets of any size. Point cloud data, no reduction in resolution. It does not require any massive computing power, and it's extremely fast to load and use. So what you're looking at here on these two look like photographs below are not actual photographs. They are point clouds. And basically you're navigating through, I don't know how many millions, if not billions of points that are associated with these clouds in real time. And so it basically changes everything on the visualization side of things. The UD technology, the basis is that it has, this is the way I understand it, at least at this point. I haven't got my hands on the technology yet. But we're in the process of talking with them to get a pilot put together. Basically, they put together a search algorithm that establishes 1 point for every screen pixel. They call it animization. It provides a seamless image of the thing. You can zoom the large and small scale. It does not add resolution as you zoom in. It's all present. And it's photographic quality. There is no reduction in resolution. And then also somehow it actually also reduces the size of the cloud, so it's a more compressed than what you would deal with in an overall point cloud type environment. So as I mentioned, we're currently talking with them to put together a pilot project, test out their technology. We'll use it as our central quadrangle, which we've just finished doing an exterior and interior point cloud of 37 halls, 1.7 million square feet. So we've got that information. We also have terrestrial LiDAR from Cook County for all the ground features and other items that are not inside the buildings. They're up just on the exterior. We also have existing BIM models for all those buildings, so we can use that as part of the process, and then we'll put it into a Cave 2 and visualization environment and see how well it looks. So this is a huge possible change in how we will deal with it, because if this technology actually works, the SDI probably won't be used for visualization purposes. We will just use point clouds. And where point clouds aren't available, then we'll just do our best effort. But over time, eventually, with all the price points coming down with LiDAR technology, there's even some handheld technology coming out now and so forth, that a lot of this stuff may just become point clouds. One of the things, and again, this is all very preliminary, we're just trying to get our head around what it all means now, but it could result in much more simplified physical models now, where we just deal with points in 3D space and get unique IDs. So we can zero in on stuff and then just view it. And we still have a special XYZ in relation to everything else, but in terms of visualizing it, that's, the cloud. The questions then are, do we still need some geometry and things for modeling purposes? And we probably do, so we probably will need some level of abstraction. But if we do have the ability to manipulate very large clouds at high accuracies and high resolution, then we can probably do a lot of spatial extraction directly from the clouds. It can't be anything that would fall out. So this would be a major change. So we're going to have to evaluate this before we kind of take on the visualization part on the SDI any further. And it's actually a really good thing, because managing the textures and surface mappings on the modeling process is very difficult and problematic. And so if that can get eliminated from the process, that will simplify the final SDI model quite a bit. Okay, so with that, let's just move into sort of the conceptual design of the SDI program. And again, we're dealing with planning, design, construction, and management. So for planning, it would be like space optimization. Obviously, we have to have the ability to map that and use our SDI for that purpose. For design, we put out program packages and design evaluations. So we basically send you a 3D model of the campus as part of your capital project design. If it's an existing building, we can give that to you and model it within, and we probably will model it within our existing SDI to evaluate your design. In construction, there may be some things that we do in eBuilder on stuff for management of payouts and stuff, visualization of that and the spatial model of it and so forth, that could provide some real fruit and validation process. And then obviously on the management side, we've got Kobe, which we're planning on extracting out of the BIM, putting in an asset management system, and then just being able to visualize the environment and be able to access a catalog. That would be a huge thing for our folks. So just a real quick study on building efficiency. It's an example where, we could do a program development specification and basically put that in there as part of the packet for a design. And then we would plug that energy model in for building performance. So we would actually go through and evaluate that in the model process itself. So that would be a big deal and a big improvement. Also in quality and construction and control, so there'd be some things that we do with scanning and so forth to make sure some of these more precision construction techniques are actually done at the time they're done. And we pay attention to it, and then we get a deliverable. We can do tolerances, checks, and things like that to make sure that things are done properly. And then obviously on the management side, being able to calibrate our building automation system. My dream is to be able to calibrate the energy modeling process on the building startup directly from an energy model, and basically calibrate the BIS from start and say, okay, that's where the building's supposed to operate. Let's see how it runs. Do our post-occupancy audit, and then go back in and say, okay, what are we going to do different on the modeling effort? What worked well? What didn't work well? What was predictive? What didn't actually predict building performance? Those kinds of things. It's really endless. I mean, if you start thinking about it, being able to spatially enable things can add a lot of value, obviously, to a lot of things that we do. So the current status. As I mentioned, we finished the SDI program plan, so we have a roadmap, and we're systematically going through and implementing it. We've finished the initial visualization testing in the Cave 2. We've got our CAD and GIS standards in place, and we've established most of the core collaborative partners that we're going to work with in key implementation areas. So we're really looking to reach out to some key people to help out, that are knowledge leaders and can help with some of this process. I mean, we just don't have the capability to do it all in-house. The next steps, completing a system of record and establishing the standards and methods. I think that's probably the big thing. So the BIM standards will be in place, mid-2015. We're in the process of that, putting that in, those standards in place now. We'll have to evaluate the Euclideon technology in 2015. I think that's pretty obvious, given that this could be a paradigm shift in how visualization works. For GIS, for system of record utilities, we're in the process of building that model. So all of our steam tunnels and pipes and things that we've got on campus, and we don't really have spatial representation and information. We're going to hopefully get that done in the GIS in 2016. System of record for existing buildings, there's actually a long time horizon on that. We'll have to scan them, do whatever, but there's some major work that needs to be done on some of that stuff that isn't coming out of a BIM model, out of a project. So that has a very long time horizon, obviously. And then building the system record, data harvesting, central repository. Buildings, hopefully by the end of 2015, will build a model that'll actually do that. And then once we have the model that'll do that, then we need to build the data modeling tools in Oracle Spatial to help manage that data. So that would go on in 2016. So next steps for the harvesting a central repository. We actually started that a little earlier in 2014 because we found a good collaborator to work on that. So we're working with Zoni Graphitek, which is iScope out of Italy. And they do a lot of work in CityGML right now, working with GIS data, and they're interested in doing BIM. So we will collaborate with them and already are collaborating with them to help build a base model and then continue to build that out. I mentioned before, ESRI just extended some support on CityGML data, which is great. So we'll try that out and help use that for GIS data migration. And the building data management tools in 2016. Building out Oracle data spatial repository management system. We'll have to go out and get help with that, and I've got a couple people in mind that could help us in that area. That is going to be a specialized product to be built to do that management system. And that's it. Thank you for attending.
Wow, that was, I think I can speak for several from the questions coming in of, wow, that is awesome. Phenomenal, groundbreaking work that you're doing, Scott. I just want to know when the tour is, because I'm ready to come down and see that virtual environment. We do have some questions, and we have time, 15 minutes for it. I'd like to go ahead, and we had 3 people basically who send in loads of questions, and so I'm going to leave it to them to ask their questions. And so Roy, Davey, we'll go ahead and start with you. I'm going to unmute you and see if you can ask your own questions. Roy, are you there?
Yes, I am. Can you hear me?
Yes.
Okay. Well, Scott, first of all, obviously you're in this process. Where are you now in this entire process, and when do you? What kind of time frame do you see for completing it?
I haven't thought about the whole time frame because it's just too big. I think I showed some of the major milestones that we're doing it. I mean, it's going to take 5, 6, 7 years, easy. I mean, there's just no doubt about it. Part of it is that we obviously have to build some of the spatial data now. Like I mentioned, we don't even have our utilities in anything. So we have to build that in the GIS. So we're still building, building representations. We're building the building representations in 3D GIS now, because it doesn't exist. It sits in CAD. So, we're almost done with that. That took about a year to do. It's going to take a while. I mean, it is going to take quite a bit. So we'll just take the main pieces out and pull them in as needed. And we'll start very small, obviously. So on the on the city GML model, it'll be very simple. It won't include a lot of objects, but it'll be functional. And the main thing is to getting all the other spatial information from different sources into one format so they can be used in combinations and together.
And as we've already seen, you discovered new technologies along the way. So over 6 or 7 years, you may make investments that are going to need to be redone.
True. That is possible, but I do think because we hit the city GML model process, I think that's a robust modeling process. Changes will occur in SRI, changes will occur in BIM, the technology, as the market determines those things, but that's not what our model is going to sit in. So, there may be some things that will change our targeting and our templates a little bit, but, the central core model is going to be pretty solid. And there's a lot of work in Europe going right now using that central model for environmental modeling purposes, so I know it can be done.
Thanks, Scott. Then my last question is, from a 30,000-foot perspective, what are the major ROI features that you see in doing this? What are you going to get out of it?
Well, I think one of the biggest things will be just I think the biggest payouts will be in areas that we don't even think about right now. Like I mentioned, the one thing in the energy modeling side. If we can get better at energy modeling through this process with spatial data and making it a more rigorous process and validating it and moving the models through and doing that life cycle part where we come in and figure out what we did well and what we're wasting our money on, if we can just save 10% on energy consumption in the campus, that's an enormous savings. And I do not think that's an unrealistic expectation at all. Right now, I know I can't put a dollar amount on it, but the amount of time staff runs around trying to figure out what we've got, in the existing facilities. So we spend a lot of time. We either we don't do it or we spend money doing it. So we make our consultants survey everything and so forth. So eventually we get to the point where maybe we don't have to go out and survey every single thing anymore. We can give them a really good data set, and then they can just do change detection and things like that. That's another big savings there. And so those are just some examples, and I think the overall footprint of the program is relatively small. It's under $1 million, and we should be able to find them. I have no doubt that we'll be able to find $1 million or more than that in value once this thing starts being put into operation.
Thank you.
Yep.
Okay, I have a question. Well, I'll go ahead and put Peter Brigham on the line. So, Peter, you should be unmuted. Can we hear you, Peter?
Can you hear me?
Yep.
Yes, sir.
Excellent.
Welcome.
Thank you. Scott, thanks so much. It was a great presentation, Michelle, for organizing this. You touched on about $1 million budget, but could you talk a little about your organizational structure, especially how it relates to your university IT support, and maybe a little about how many people, FTEs, you have working on this?
Yeah, we do have an IT services group that we work closely with in terms of our applications and obviously in our environments, our networks, our infrastructure and stuff. So we have a good working relationship. We basically have a dedicated team of 4 or 5 people that work directly with facility services on projects. They will be our Oracle DBAs, so we already know we have to train them to manage the Oracle spatial side of things because they don't currently have it. So we will add and supplement where we need things, and we'll help pay for some of that. So we've got a good working relationship with them, so that'll continue on as we move forward. In terms of our facilities group, there's myself with just doing the GIS and the BIM modeling side of things. We have a CAD. We have 2 people working on the CAD piece, and then we have an application developer and then a generalist, and then my boss. So that's our group right now. We have we use interns to help us with some of the data capture and things like that. So I have 2 or 3 interns that over the course of the year that help us with the data gathering.
That's great. And a little bit of a follow-up. You touched on BIM standards and some of the standards you're developing. Does that include some specific contract languages? You work through the state system on a standard contract for architects, designers, and what kind of language are you trying to put in there to make sure you get usable data to feed
Yes.
the system?
Yes, it will include contract language. It will be part of the contract. We will have different levels of requirements depending on the type of project and the scale of it. But I'm going to be even more definitive than that. And I think one of the things that we're going to want at least 2, there may be more, target templates out of the BIM process. One will be pushed to a CAD model that will immediately go into facilities management in Archibus. And then the second will be one that will be essentially decompress the BIM model into an SDI formatted template that we can then consume directly in. So they will be required to do that. We will have to build targets. There's no way I'm going to let them, just give me a model and have me go in and pick and choose and figure out what the layers are and everything. It'll be part of the. So we'll pay for that, but it's part of the contract. I mean, you're right out of the box. That's what you got to do, and we will test it in interim deliverables as the project's being designed and constructed to make sure it actually works.
Right, and at milestones, right?
Okay, exactly.
And final one from me, just could you talk a little more about the decision to go with City GML? I think I understand the open standard and what sort of flexibility and innovations going on there. What we're dealing with, a lot of the firms are, of course, very that we work with are very Autodesk-centric. They understand the sort of limits of what they're doing in BIM, but what they're pushing is more a Navisworks, federated model approach.
Well, I think that's what we decided to do is divide and conquer on that. I mean, I think that, again, our deliverables and our work occurs in BIM, GIS, and CAD. I mean, that's what we vendors supply. That's what they do their work on. That's how they construct the building. We're not going to change that, and we're not going to change that anytime soon. But we have to be able to consume that information and be able to push it out into a central model, so that's usable by everybody. We just decided that just the semantics and ontology and the modeling and the LOD versions, I mean, it's all built inherent in the model, so there's a lot of elegance in it that provides a lot of power when you're sitting there trying to spatial model. So when we're working in the environmental lab, we had to create a pseudo LOD environment to get it to work. Well, that's just created out of the box, City GML. So that's just one of its many capabilities. So that would go away. It just has just the semantics and the ontology and how they've structured it, and the fact that it's also a surface model, which I think at the end of the day you're going to want to model your stuff as surfaces because that's how you understand it and manage it. So it just has a lot of power. So we don't expect people to give us, City GML data anytime soon. I mean, it may happen at some point, but we're going to have to harvest it out of the systems of record.
Great. Thanks again.
Yep.
Thank you, Peter. Okay, we have a question here from John Presla. I'll put you on, John.
Oh, I know John.
Are you there, John?
I am here. Can you hear me?
Yeah, did I pronounce your last name correct? That's a hard one.
Prisbilla, but pretty close.
There we go.
Hi, John.
Hey, Scott, how are you, man?
I'm doing fine. How are you?
Good. Hey, my question has to do with attribution. Incredible visualization and everything that I've seen, and I really like where you're going with point clouds. But if you're trying to do things like space management, which you mentioned early on, and of course asset management, attribution becomes very important both for spaces and for physical items, equipment, and so on. Can you talk about that a little bit?
Yeah, I think right now, John, what we're trying to do is just make it as simple as possible. So there will be a unique ID that will link in with the various asset objects. that will be managed as part of the process. So, I mean, that's how we'll link it out to Maximo or to Archibus or to whatever else. So we can extend the CityGML model. There are extensions that can put attribution to run and be managed as part of the spatial process, but I think we'd like to keep the two separate to the extent that we can so that we're managing spatial data only, and then the other folks, provide the attribution management in another form and another, with using their own day-to-day system. So, as you know, it's always a big problem how to manage that process, but I think we have to let the SMEs handle certain parts of it that are going to be managing the attribution in terms of the pumps and the motors and the inspections and all the other records that are going with it. But right now we're only planning on linking it with an ID to bring it into the object. And I think with the cloud changing stuff, that's kind of what I'm thinking is that, I don't need to carry all that geometry if I've got a spatial representation and I can create the geometry on the fly if needed. If it sits in a point cloud, I can just give me a point that represents a motor and link an ID to it, and that's pretty easy.
Okay, thank you,
Right,
John.
but what if you had a scenario in which somebody said, I want to go inspect the entire campus, all the nominally ADA compliant restroom facilities, and I want to check them versus the new ADA standard that just came out.
Yeah.
I'm on a route to do that.
Yep. That one we haven't completely solved. So that is an issue. But I think if it comes over as geometry and stuff, and if we provide a system that manages that and links it to the asset, and there's a process in place to keep that managed, it's probably doable. So, but yeah, I agree with you. There's some issues there.
Okay,
and that may be a pretty tall expectation anyway.
It is. Yeah, there are some issues there. But yeah, I mean, just managing it, just trying to get a spatial representation, even a simple one in Maximo is not going to be easy. So.
Okay, we're about over with our time. Don't want to hold up people too much, but we do have just one last question that I'd like to shoot out there for you. And this comes from Tom McCaffrey from UChicago, and that's about the support. We all want to know how you get support with these kind of endeavors. So how did you get your senior administration to buy into your vision? And I guess where do you get your monetary support for projects of this magnitude?
Well, again, that was interesting, and I think we're just fortunate that we had a senior leadership group that understood what I was saying and got it. That didn't take a whole lot of explanation. Once we laid it out for them, it's pretty much the way I did with you guys. They got it, and they're already feeling it in some regards in just their day-to-day work. So they understand that they're building this monster, and they're spending a lot of money acquiring this data, but they're really not managing it well. So I think they were willing to take a move and actually move it as part of this process. So as far as the funding is concerned, yeah, I mean, right now we're small, and once we build this infrastructure, it's going to become more expensive to maintain it. So we're going to have to provide value as we go along, and we'll be looking for opportunities, strategic opportunities along the way to show that value to the administration. I just think the visualization side of it will be the one that we'll do early. So being able to do some evaluation at the administration level where they can actually visualize the new environments, it's important to them. And if they can actually see it and understand it and evaluate a new building or a rehab building before committing millions of dollars on it and feel comfortable that they know what that's going to look like, that's going to provide a lot of value right there and help support the program.
Well, I know that I'm speaking for everyone when I say we really enjoyed what you put together for us today. The work you're doing is extraordinary, and I know I personally will look towards University of Chicago for some leadership in those areas once we get down those roads. I do also want to thank all the attendees who joined us today. We did end up having 65 folks from all around, and It's by collaboration efforts such as these that we are all growing together and making our industry the full value that it's capable of. The next webinar in the Geotech Showcase series is scheduled for January 20th at 1 p.m. And that presenter will be me, Michelle Ellington from the University of Kentucky, and I will be speaking on building a university enterprise GIS from the ground up. I hope some of you can make it. And for more information on future webinars in this series, please do visit the CFTA website at www.cfta.org. And with that, thank you, Scott, very much for your time today.
All right, thanks, everybody.